Welcome back to the Jasa channel. In this episode, I'll be upgrading the flashlight from the last video, but first I need to make a battery case. I'll use these triangular rods to separate the batteries. And so as I apply a lot of heat to the glass, it very quickly changes its consistency. It begins to flow like a liquid, it acts more like a thick syrup or honey, and then very quickly solidifies back into a solid state. Now I need to tag these two pieces of glass together, so I'm going to push it up a little bit to make sure they're contacting. If they don't contact, as I heat it up, both pieces of glass could condense away from each other and make the situation worse. I need to test it, but it wouldn't be smart to stick a battery in there being so hot. So this rod's the same size and it looks like it's gonna fit. And I'll bench cool it in the outermost part of the flame. And so I came up with another flashlight design while I was making the first one. And so I couldn't help myself here, but I'm gonna have to make it for you. And that's kind of one of the parts I do enjoy of the process, is the design and engineering that goes into a more functional piece like this. So this design is based on the shape of the batteries. I have to use 4 batteries, so I'm going to use 2 tubes that will fit 2 batteries and then combine them in the middle and use 2 LEDs. So by holding the tube sideways and rotating, the glass contracts back and forms a nice lens. So if I hold the tube downward as I rotate, it'll make a more pointed lens, it'll make it more convex. But by holding the tube towards the ceiling, it'll make the lens flatter. It'll make it more concave. So I'm going to use a really small flame and heat up a very small area and puff out a little bubble. Then use a rod to open it up in the flame. This is actually a really safe method of opening up holes in tubes. And then I'll do the same for my other tube, that way I can connect them together. That'll create a little hollow channel where I can run my wires and even a little button for an on-off switch. And then to make this connection, you want to make sure both sides are very, very hot, very molten, and you want to connect them in the flame. And then if you want to make a larger chamber, it's easier to do a smaller connection and then just blow it out rather than trying to connect 2 large holes together. And now if there's a hole in your connection, a good way to fix it is to move some of the surrounding glass over it or to dab on some new glass. I did get a hole, but I'm going to open it up for the switch. If you try to melt the hole closed, it might condense the glass back, opening it up and making the hole even worse. And so as I'm taking apart this old controller for battery parts, I find this old Rumble motor. I wonder if I can run it on batteries. And now 2 batteries. Wow. And now for the big guns, the 9-volt. And so I'll go ahead and bend that wire connector and drop it into the back of the flashlight to complete the series connection. And hey, it's Inspector Cuddles, checking up on my work, making sure it's satisfactory. I think he's given me the okay. And now to connect my wires, I'll go ahead and bend some hooks, connect the hooks together, and crimp it closed. And this isn't the most durable connection. If you're planning on a more permanent project, you'll want to use solder on your wires and solder them together. And since I'm using a switch on my next flashlight, for this one I'm just going to push the wire down to contact the battery. So I'll press it down, and let's see what happens. Oh, it's working! Awesome! Look at that, it's really bright too, much brighter than the first video. So the Cree LED is similar to the LEDs in the last video, except to achieve a higher brightness, it's multiple LEDs combined onto one chip. And then for color changing LEDs, it'll have red, blue, and green LEDs, and then whatever color you pick will set the voltage for that color. And now I believe that dash represents the negative or the cathode, and if you end up getting it backwards, it should be okay. Just flip your battery around and it should work. And now for the second flashlight, I'm going to wire in a push button switch. And switches are pretty simple. They basically just connect and disconnect the circuit. So when you're not using it, it disconnects the battery, and when you push it down, it reconnects it. So I connected my switch to one of the wires, and now I'll connect the other side to the battery contact. The other wire is also connected to a battery contact. And because I'm out of battery contacts, I went ahead and took a spring out of one of the LR buttons on the controller. I bent it around and I'll contact batteries with that. Alright, let's see if it works. Alright, I'm excited to get that one working. And just to keep things simple, I'm just going to use some electrical tape on that spring. And now don't forget to hit that like button if you've enjoyed what you've seen so far. And also make sure to subscribe. I've got a few more really cool LED projects planned and you don't want to miss them. Now I'm going to finish up big and wire up 6 of these LEDs for the last light. But while I do that, I wanted to talk about something called amps. So in the first video, I compared the electricity to a pipe pressurized with water. And so if the water pressure would represent the voltage, then the amount of water in the pipe would represent the amperage. So looking at that rumble motor I was using, the more voltage I applied, the faster it was running, but the more amperage I would have, the longer it would run. So real quick, in my magic wand video, I talked about a project I got commissioned for, a Halloween staff. And here it is. It actually won 3rd place. So I used a green, yellow, and clear frit to give it a semi-opaque color for the LEDs to shine through. And then here's a sneak peek of my staff. It's a staff of light. It's a prototype right now. The real staff of light will be blindingly bright, much brighter than this one. But now to finish off the flashlight, I'm going to go ahead and wire 2 9-volt batteries into a series, creating 18 volts. 6 LEDs connected series and parallel. Let's see if it works. Well, there seems to be something wrong here. A little bit of trial and error sometimes with projects like these. The connections seem okay. Let's try some fresh batteries. Oh, there we go. That's what was wrong. Alright, now it's time to run the test. For test number 1, it is the single LED. This is the one that I had to make the battery pack for. It's looking pretty good, but I need something to compare it to. So here begins test 2, the dual LED. And I think the second one does look brighter. And so I saved the best for last. Let's bring out the big guns, 6 LEDs. So here they are, side by side. Alright, I think that'll wrap it up for this video. Thanks for tuning in to the Matt Jasa channel, and always, have a great day.